Alrighty, guys. So again, 321, you'll have one very similar to it on your exam. But yeah, you just have to identify the limiting reagent by doing stoichiometry 2 times, and then whatever produces your smaller number, the chemical that produces it is your limiting reagent, and the yield is going to be the smaller value, so 3.44 grams of CO2, and then you can use your limiting reagent to do stoichiometry again to find your other product. If you want, you can do stoichiometry 2 times for H2O as well, but it's kind of a waste of time because if you do it with 10 grams of CH4, you'll get a bigger number anyway, so we can just skip that step. And then actual yield divided by theoretical yield gets you your percent. Okay. Any questions? Okay. All right. Just know you will have a problem very similar to this on your exam, and you will have to know what a combustion reaction is. So just as a reminder, combustion reaction is when a carbon compound reacts with oxygen gas, which is O2, and it produces CO2 and H2O. So you literally just can memorize the product CO2, H2O, and it's a reaction with oxygen gas. Okay, so let's move on to the next problem, 3.22. That's the one that I want to spend a bit of time on because it has to do with empirical formula. So it's not anything that's completely new, but it's in a format that'll be a little bit different for you guys, okay? And you will have a question like this on your test, okay? All right, so we have an empirical formula. So here it tells us a combustion analysis of a hydrocarbon produces 33.01 grams CO2, 13.51 grams of H2O. Calculate the empirical formula of the hydrocarbon. And you might be like, what the heck is this? Okay, but we have a good start because we all know what a combustion reaction is, right? So a combustion reaction is when we have O2 reacting with something that has carbon in it, and it produces CO2 and H2O. Okay, now you have a compound, a class of compound called hydrocarbons. Do you want to guess what hydrocarbons are made out of? Yeah, hydrogen and carbon. Those are geniuses. All right, so we don't know the formula, we don't know the empirical or the molecular, so let's just set it up like this. I like to use question marks just to know. Just know the question marks aren't equal to each other. They might be different numbers, they might be the same, who knows? We're trying to figure that out, okay? But this is your general chemical reaction right here. Okay. And again, it's combustion, and so it's carbon-based, reacting with oxygen to produce CO2 and water. All right, so here, the next pieces of information that we are given is that we have 33.01 grams of CO2. And the other piece of information is that we have 13.51 grams of H2O. Okay, and what we're trying to do is we want to figure out what is the formula for this hydrocarbon right here, okay? Any questions on the information that's given in the problem? Okay, that's pretty much all that we can get for now. All right, so what we have to do basically is figure out how many moles of carbon and how many moles of hydrogen there are in this system, in this reaction, okay? And the way that we do that is by looking at the products, because we know how much of each product we have. God bless you. Okay, now, if you guys take a look at carbon, okay? So there's carbon in this reaction. Where does all of the carbon in this reaction end up on the product side? Which chemical does all the carbon go into? CO2. So let's write that down on our paper, okay? So all of the carbon is in CO2. You guys notice, right? It reacts with the oxygen, and all the carbon ends up in CO2. Okay, the other component of the hydrocarbon is hydrogen. Where does all the hydrogen end up? H2O. So let's jot that down too, okay? So all of the hydrogen is in H2O. Okay, so what we should be able to observe is that all the carbon ends up in CO2, all of the hydrogen ends up in H2O, okay? So if you can figure out how much carbon is in the CO2, then you can figure out how much carbon was inside of this hydrocarbon. If you can figure out how much hydrogen there is in H2O, you could figure out how much hydrogen there was originally in that hydrocarbon. Yeah. What do you mean? No, because of the masses. With that you can find molar mass. That's when you have 1 mole, right? But we don't know how many moles we have yet. So that's what we're trying to figure out. It's a good question though. Any other questions? Or does that make sense so far? All the carbon goes to CO2, all the hydrogen goes to water. Okay, so I'm going to show you guys how to figure out how much carbon is in here if you got 33.01 grams of CO2. And then I'll have you guys try one for H2O. Okay, so let's take a look at CO2. So the first thing that you want to do is you want to find out the molar mass of CO2. Okay, so I want you guys to go to your periodic table, and real quick, I want you guys to write the molar mass of CO2. Ah, bless you. All right, so hopefully you guys found out that CO2 is 44 grams per mole. I think we did it in the previous problem too, so yes. So carbon, you can always round to 12. And so if you wanted 44.01, you can, but it's not going to make a difference in your calculations. Good question, though. Okay, so CO2 is 44 grams per mole. Okay, so what we're going to do now is we're going to find the mole ratio. So basically the percentage of CO2 that the carbon takes up by mass. So if we take a look at the periodic table, carbon is 12 grams per mole. Okay, CO2 is 44 grams per mole. Okay, so if we divide the mass of carbon by the molar mass of CO2, what we get is the mole fraction. We can figure out what percentage of CO2's mass comes from the carbon. Okay, so what we're going to do is 12 divided by 44, and that's going to give us the mole fraction for carbon in CO2. So we end up with 27%. And this is going to be, if you want to label it, this is the mole fraction of carbon in CO2. Okay, so 27% of CO2's mass comes from the carbon. Okay, I'll pause right there. Any questions so far, or does that part make sense? It's just mole fraction. I think we talked about this in the previous unit. Okay, so if we want to find out how much carbon is in CO2, it's very simple. Now that we have the mole fraction, we know that carbon takes up 27%. We just have to multiply that by the mass of CO2. So 33.01 grams of CO2. Okay, so carbon takes up 27% of that mass. Okay, and what that tells us is that CO2, we have 33 grams of CO2. Well, 9 grams of that comes from the carbon. Okay, so that's how you can figure out how much carbon there is inside of this system. Since all of the carbon went to CO2, that means this compound right here has 9 grams of carbon inside of it. Okay. Yes. That's close enough. Yeah, I rounded it. I got 9.002, but yeah, I just rounded to 9. It's just a nice clean number. Yes. Exactly. Exactly. Yeah, percent comp is another way to look at this. All right, do you guys think you can find out how much hydrogen there is in the system? Yeah. All right, maybe a little too early for that. I'll give you guys about 2-3 minutes. Try it out. It's very similar to what we did here. Again, find the molar mass of H2O, and then find out how much the mole fraction of hydrogen, and then try to figure out using the 13.51 grams of H2O. So I'll give you guys a couple minutes to try that out. You can work with the person next to you. If you have questions, come ask me. I can help lead you a little bit. But again, it's very similar to what we did with CO2, just with H2O. Okay, take about 3 minutes to do that. Alrighty, guys. So I have the answer for the next part up here on the board. You guys should have gotten about 3 grams of hydrogen, something close to that. Okay, the key here was to identify that in H2O, there are 2 moles of hydrogen, right? So you're gonna have to have 2 moles of hydrogen accounted for. Okay, because in CO2 there's only 1 carbon, so we can just use one of the carbons. But here H2O has 2 hydrogens, so it's going to be 2. Yes. Oh, am I stupid? I am stupid. Thank you. 1-1. Thank you. Yeah, that's just gonna have everything. So 1.5. Sorry about that, guys. It's very early for me too. I don't know how you guys are learning this. All right. Any questions about that? Sorry about the mistake. Yeah. All right. Everyone get about 1.5 grams of hydrogen? Okay, again, the key here is that H2O has 2 hydrogens, so make sure you account for 2 of them, not just one. Okay. Sorry, what was that? Yeah, it's 1.5 for H. Yeah. Sorry, I can't hear you very well. You could, yeah, as long as you understand that it's 1.5 grams of hydrogen in the system total. Yeah. Yeah, the way that you denote it is however you want to, as long as you can keep track of it. Yeah. Mm-hmm. I got 0.06, but then I got the same. Interesting. It's 2.02, right? Yeah. Might have pressed the wrong button or something. Yeah, it's okay. It's okay. I made a mistake too, so I have to forgive you. All right. Yes. What was that? 1.5 grams of hydrogen. Yeah. Okay, so let's move on to the final component. So we now figured out how much carbon and how much hydrogen in the system total, right? And so what we got to do now is figure out the empirical formula. Now, when we put in the numbers in the chemical formula, we can't use grams, right? We have to use moles. So what we're going to do is we're going to convert carbon and convert hydrogen to moles. So I will give you guys about a minute. I want you guys to convert the carbon into moles of carbon, and I want you to convert the hydrogen into moles of hydrogen. And then after that, we can find out the empirical formula. What's up? Yes, it's in the white binder. Do you see it right there against the box? Alrighty, guys. So for the conversion from grams of carbon to moles of carbon, all you have to do is divide by the molar mass, which is divide by 12, and that should give you 0.75 moles of carbon. Hydrogen, pretty easy. Just divide by 1, so you can just skip the math. It's just 1.5 moles of hydrogen. Okay. Any questions on the conversions, grams to moles? Just molar mass. All right, so now we are finally ready to figure out what the empirical formula of this hydrocarbon is. So we have C 0.75 and H 1.5. Okay, well, we can't have decimals for our empirical or for our chemical formulas, so we just divide by the smallest number. 0.75 is smaller than 1.5, so you divide both numbers by 0.75. That's going to give you C1H2. And that is the empirical formula of your hydrocarbon. Yes.
Why are we not using H2
for the molar mass? Yeah, great question. So the reason why we used H2 for this part right here is because there's 2 moles of hydrogen in water, right? But once we figure out the mole fraction and we multiply, this gives us the mass of hydrogen, not H2, just one hydrogen, all the hydrogens combined. This is taking into account the ratio between H2 and H2O.
But it's when it has to be.
That's hydrogen gas. Hydrogen gas is diatomic, but here we're talking about just all the hydrogen in the system. Yeah, that's a great question. So yeah, here we're talking about H2 because we're talking about the ratios. And then after we find the mole fraction, we're talking about all the hydrogen system total. Yeah. Oh yeah, sorry. For the empirical formula, right? Or are you talking about to get the moles right here?
No, I mean like how
No, you can finish your thought. You're good. Okay, I'll go over with you in a second. Okay. All right, so the empirical formula is CH2. You could, but typically we write the carbons first. But if you did like H2C, like you're not gonna get docked off. Yeah. Good question. I don't know. Some nerds decided we do that, and we just listen to the nerds. Yeah. Any other questions? Yeah. Mm-hmm. No, technically you would be giving a more accurate answer, but I mean 0.02 is not going to make a big difference in your calculation. At the end of the day, you're probably going to end up with the same number. So I just cut it off. Most people just cut it off because it's easier. Yeah, less punching in the calculator. Good question. Any other questions? Again, as long as the numbers are close, you won't get docked any points. Yeah, like if you gave me like 10 grams of hydrogen, then you'd be wrong. But like 1.4, 1.6, you're totally fine. Okay, so what we're gonna do now, I'm gonna give you guys some time to struggle because this next question is a killer question. It was in the 1982 AP chemistry test. Hey, that was before even I was born. Yeah, what's up?
What was the
CH2. Okay. And this is a monster question, guys. The first time I did this when I was in high school, it completely went over my head. So I want you guys to have the same opportunity and suffering to try it out. It's pretty much the same concept that we just went over, okay? But it's just a lot more difficult. And part of AP Chem is learning how to struggle and figure things out on your own. I will go over this with you, so don't worry. I'm not just gonna leave you hanging. But I want you guys to take some time. You can work with the person next to you. I'll give you guys about 7 minutes to suffer, to try it out. If you can get it, then you are in great shape for the AP test. Because again, this is an FRQ that came from 1982, and the test was significantly harder back then. It's gotten easier over the years. So try it out. I know I kind of hyped it up a lot, but give you guys about 7 minutes to try it out. Similar concept as before. It's empirical formula, mole fraction, things like that. But try it out, and then we'll start going over it in 7 minutes, okay? So good luck, guys. All right, so if we're looking at this question, this is all the info that I can pull out, okay? It tells you water is added to 4.267 grams of UF6. So that's our two reactants, right? UF6 reacting with water, and you got 4.267 grams of it. Everyone good with that part? Okay. And then it tells you the only products are going to be 3.73 grams of a solid, and that solid has only uranium, oxygen, and fluorine. So we don't know what the chemical formula is, but we know that it's solid. It's 3.73 grams, and it's made out of uranium, oxygen, and fluorine. So I got this from that part. Everybody good with that part? Okay. And then lastly, it tells you that it produces 0.97 grams of a gas. So I got that right here, 0.97 grams of a gas. And the gas is 95% fluorine, and the remainder, so 5%, is hydrogen. That's where I get the rest of this, okay? Everybody good with all that information? Okay, so one of the trickiest parts of AP Chem is looking at this problem and pulling out all the information that you can get, and then just try to write it in a way that makes sense to you. If you organize it differently than I did, that's totally fine. But you should have gotten something like that for your, I guess, your beta, your alpha chemical reaction, and then just this information about those compounds. Okay. All right, let's do part A. So for part A, it's saying from this data, determine the empirical formula of the gas. So we are looking at the gas that is produced, so this right here, okay? Well, the information that we have here is the total mass and the mass percentages. We're looking for the empirical formula. If we're trying to find the empirical formula, what we're trying to find is we're trying to find the moles of hydrogen and the moles of fluorine, right? Because to find the chemical formula, we need moles. So what we got to do first is we got to find the grams of H and F inside of this gas, and then we got to convert it into moles. Okay. Luckily for us, we have the percentages in terms of mass. So it's like what we did in the previous problem, but they kind of did some of the work for us and gave us the percentages. So our total mass, I'll start right here. Our total mass is 0.97 grams. This is the total. If we want to find just the fluorine, that's going to be 95%. So 0.97% of it is going to be fluorine. Okay, so all we got to do is multiply the two numbers together. So 0.97 times 0.95, and that'll give us a total of 0.9215, and this is grams of fluorine inside of this gas. Okay. And again, guys, the question on this the test will not be this difficult. This is way harder than anything that's on your test, probably even on the AP test. Okay. Okay, but I'll pause right there. Any questions on how we got here? The 0.9215 grams of fluorine. Yes. Because to do the multiplication, you have to put it as a decimal. So you move the decimal twice to the left. Yeah. Okay, let's do the hydrogen now. So if you want, you guys can do the very precise way of 0.95 grams, or sorry, not 95, 97 grams total. And then you can multiply that by 5%. Okay, or since you know that this is only made out of fluorine and hydrogen, you can just kind of take it easy and just subtract, excuse me. You can just do 0.97 minus 0.9215, and that'll give you the same answer. Your hydrogen is 0.0485 grams. So you can do it either way. You can do the equation to find the 5%, or you can just subtract the fluorine from the total. Either way, you're going to get about the same number. Alrighty, so you got your grams of fluorine and your grams of hydrogen. Any questions so far? Okay, from here, we got to turn them both into moles, okay? So to turn grams into moles, you just divide by the molar mass. So for fluorine, you are going to divide by the molar mass of fluorine, which is 19. And then for hydrogen, you're going to divide by the molar mass, which is 1. And I'm sorry that my work is turning into like a sideways T, but just trying to fit it on the screen. Okay, so I'll give you guys a second, or I'll give you guys about a minute or so. I want you guys to convert the grams into moles and see if you guys can get the empirical formula. Finish it up on your own, okay? Give you guys a minute to do that. Alrighty, guys. So if you guys divide by the molar mass, you guys get the same number, right? And then if you divide by the same number, you get 1 of each. So the empirical formula for the gas is HF. Okay, so there you go. That's your answer for part A. Part A, the answer is HF, and it's because once we do all this stuff, we get 0.0485 moles of F and 0.0485 moles of H. You divide by both of them, you get 1 for both. Okay, there you go. Yes. So not a stupid question. If you did FH, that's correct as well. It's just, again, the nerds usually put H first for diatomic compounds like this. But if you did FH, it's totally correct as well. Yeah. Alrighty, any questions? All right, let's move on to part B, and I think part B is where it starts getting pretty annoying. There's a lot more math to it. I'll leave the question up for now, but again, I'm going to take it off, so if you need it, please have it on your Chromebook or take a picture. Okay, so it's asking what fraction of the fluorine of the original compound is in the solid and what is in the gas after the reaction. Okay, so let's dissect this real quick before we start doing the math. If you guys take a look at this system, all of the fluorine comes from the UF6, right? And then it breaks apart after the reaction, and some of it goes into the solid that's made of U, O, and F, and some of it goes into the fluorine that's HF. Okay, does that part make sense? Okay, so what this question is asking is basically how much goes into the solid right here and how much goes into the gas right here. Okay, so I'm gonna need the whole screen starting now, so take that down. All right, so if you take a look at UF6, okay, let's start by looking at the total mass of UF6. You start with 4.267 grams, and this is the total mass of UF6. All right, like we just said, all of the fluorine inside of the system comes from UF6. So that means if you want to find out how much fluorine there is in total, we can just break this guy down. Okay, so what we're gonna do now is we're gonna find the mole fraction. Hold up, I'm gonna use a different color. You're gonna find the mole fraction of fluorine in here. Okay, so you want to find the mole fraction of fluorine inside of UF6, and that's gonna allow us to figure out how much fluorine we have in total. That way we can figure out how they're separated into the other two compounds. God bless you. All right, so to do that, it's very simple. It's what we did in the previous problem. First thing we want to do is we want to find the molar mass of UF6. So I want you guys to take a second, use your periodic tables, find the molar mass of UF6.
Mass here. Like
5.6.
Like,
no, we don't know that. You can't make this assumption.
oh,
Yeah.
okay, thanks.
It's 46. Alrighty, guys. So hopefully you guys got 352 grams per mole. Yes? Okay. All right. So we are trying to find the mole fraction of fluorine. And so if you look at UF6, how many moles of fluorine are there? 6. Okay, so that means what we need to do is we need to find the molar mass of 6 fluorines. Okay, and I'm going to give you guys this number just so we can skip a little time. I didn't realize how quickly the time went by. But this is going to be 114 grams per mole. Okay, and so if we want to find the mole fraction, we're just going to divide the molar mass of F6 by the molar mass of UF6. And that's going to give us the mole fraction of fluorine. Okay. Okay, so the mole fraction of fluorine is going to be 32%. Okay. All right, so far so good? Okay, so again, yes. Are you sure? Okay. So from here, we can find out the mass of fluorine because we have the total mass. Well, if the total mass is 4.267 and we multiply that by our total mass, this is going to be our mass in total, that's going to give us how much fluorine there is in the system in total, okay? So you multiply those two numbers. I'll make it easy for you guys. It's 1.38 grams of fluorine in the system. and this is in total. All right, so that's the hardest part, finding the mole fraction. And then after this, it's pretty simple. It's just making some observations and doing a quick calculation. But any questions how we got to this right here? Finding the total amount of fluorine in the system. All right, so we know that there's a total of 1.38 grams of fluorine. Okay, and now we just need to find out how much is in the solid and how much is in the gas. Well, we found the gas in the previous problem, right? How much fluorine is in there. If you look back at the amount of fluorine in the gas. Okay, sorry about that. You got 0.9215 grams of fluorine in the gas. That was in the previous section problem. So look at part A, and you guys should see somewhere got 0.9215 grams of fluorine. Yes.
Hey,
you're being recorded.
Have, that's okay. Do you have 100 milliliter flasks? By any chance borrow those or anything?
No, not 100 mils.
No.
That's I want 6 missing.
All right. Do you guys all see that in your previous the previous section? Okay. So if you know that you have a total of 1.38, 0.92 is inside of the gas. How do you find the one in the solid? Yeah, you just subtract, exactly. So subtract that for me, and that'll get you your fluorine inside of the solid. All right, should get about 0.4585. All right, now we're almost done. They want to find the percentage. So all we got to do, yes. 1.38 minus 0.9215. Yeah. Yeah, just the fluorines. All right, so once we have that one, we can just find the percentages. So we'll just pick one of them. We'll do this divided by the total, 1.38. So if we do 0.4585 and then we divide that by the total, 1.38, that's going to give us about 33%. Okay, which means if 33% of the fluorine is in here, that means there is 67% of the fluorine is in the gas. So 33% is in the solid, and 67% is in the gas. And there you go, guys. That is part B. I took the mass of fluorine in the solid, the 0.4585. You divide it by the total, which is 1.38, and then you multiply it by 100%. Yeah. Sorry, I kind of went quickly through those steps. And then for here, I just subtracted 100 minus 33. So much fun in the morning. Just AP Chem. Alrighty, guys. Any questions on B? Isn't this fun? Isn't this so much fun? I'm sorry, guys, about there's no break. I didn't realize how quickly the time went by. All right, so that's part B. I promise you it gets a little bit better from here. I think part B, actually, no, part C is pretty annoying too. Okay, you guys ready for part C? All right, so for part C, we are finding the formula of the solid product. So this thing right here, okay? So I'm gonna erase some of this information just so we have more space, but we are trying to find the formula of the UOF solid. All right, now to do that, we need to figure out basically how much uranium, how much oxygen, and how much fluorine there is inside of this compound. Okay, well, the fluorine is pretty easy, right? We just figured out there is 0.4585 grams of fluorine. Okay, we got that from part B right here. Okay, so we need to find the uranium and the oxygen. Okay, the easiest one to work with is actually the uranium. Does anyone want to take a shot at why uranium is pretty simple to find? Yeah. Exactly. So all of the uranium in here came from the UF6. So if you can figure out how much uranium is in UF6, you know exactly how much uranium is in your solid. Good catch, yes. It is the same case for the H2O. However, we don't know how much H2O was used. Yeah, they don't give us a number, right? Yeah, so that's the reason why. But let's say, for example, they said like there's 10 grams of H2O, then yeah, you could do the oxygen as well. Yeah, good question. All right, so again, just to reiterate, all of the uranium inside of the solid came from UF6. And so if you can find the uranium in here, you can find out the uranium in here. Okay, lucky for us, what did we just find out about UF6 in the previous section? Yeah, we found out how much fluorine was in there, right? So if you look back at part B, you can see that there is 1.38 grams of fluorine inside of UF6. We just calculated that. UF6 is made out of only uranium and fluorine. So if you want to find the uranium, pretty simple, you just need to subtract. So we do 4.267 minus 1.38. That'll give us 2.887 grams of uranium. Okay. Okay, so just to reiterate, we found how much fluorine is in our solid from part B. Okay, this came from the previous section. To find uranium, we identified that all of the uranium came from UF6. Okay, so if we find the uranium in UF6, we can find the uranium in our solid. In part B, we found the fluorine in UF6. So if we subtract the total mass of UF6 with the mass of fluorine, that gives us the mass of uranium. Yes. This one, oh, that was from the previous section when we found the fluorine. Because remember how we found the percentage of fluorine in the solid and in the gas? Yeah. To answer your question? Alrighty, guys. So from there, how do you think we're going to find the mass of the oxygen? Yeah, we're going to subtract from the total mass. The total mass of the solid is 3.73. So if we just subtract the uranium and we subtract the fluorine, that's going to give us our mass of oxygen, which is 0.797. I'll round it up to 2. Okay, so from there, you should be able to get the empirical formula. Yes. Or sorry, the molecular formula. Yeah, good question. So if you look at UF6, right, it's made out of only uranium and fluorine. In part B, we found out how much uranium is in there, right? The fluorine, which is 1.38 grams. So if you take away the fluorine, you only have the mass of the uranium left over, which is how we got the 2.8. And then all of the uranium in UF6 went to the solid. And so that's how we can get 2.887. You look confused still.
Yeah. Why did we subtract by
0.45. Because that's the fluorine inside of the solid. Remember, there's two compounds that have the fluorine, the solid and the gas. This is the total fluorine in the system. This is when they're separated out. Yeah, what's up?
Total grams of the UOF solid is 3.7.
That's correct.
When I found the grams of oxygen, I got a different number.
What you get?
0.3845.
You are correct because I put a 0 when I shouldn't have. Thank you. 2.887 minus 0.4585. Sorry, I think I fat fingered the calculator. You're correct. My fault, guys. I'm bad at math in the morning and I have fat fingers. Thank you. All right. Any other mistakes I made? Any other questions? Yes.
What were the givens?
The total mass is 4.2, 3.7, and 0.97. Alrighty, guys. So from here, how do you find the empirical formula? You have the grams. What do you need to turn that into? Yeah, you got to turn that into moles. So we got to convert all of these guys into moles. And then from there, you can figure out the subscripts for U, O, and F. Yes. Yeah, round that down. Round that down. Yeah, once you get to empirical formulas, there's a lot of rounding. As long as you don't have something like 3.4 or 3.5, then you can round it down. Yes. No. I didn't even give him a break today. I have to finish up. I feel so bad right now. They've been listening to me talk for an hour and a half. Sometimes I listen to my videos and it's so cringe. Yeah.
Is it a whole? It's somewhat 20 minutes.
For AP, it's like 60 plus. And I don't really have a great voice either, so I feel bad. I wish I had a Morgan Freeman voice or something, but. All right, so I will let you guys finish up that problem, but I'm going to give you guys the answer. Your empirical formula will be UF2O2. So if you guys end up getting that, great job. If you guys don't, just retry the calculation. You probably messed up on the calculator like I did. Yes. So for the balanced equation, you just plug this in. So let me, yeah, so you fill this in. So it'll be U, I guess, O2, F2. And then you just have to balance it from there. You just need a 2 in front of the H2O and a 4 in front of HF. And that's your balance. All right, guys. So I will end it there because I'm sick of talking. And I'm sure you're sick of listening to my voice. I have a recording of this so you can go back and look at this question. Again, the question on your test will not be this difficult. However, it will be similar. So what I recommend you guys do over the weekend is at least once, see if you can go through this problem on your own now that you know how to do it. See if you guys can go through it, solve it correctly, and just double check your answers. Again, if you're comfortable doing this on your own, the question on the exam will be pretty easy. It's similar to this, just a lot easier than this one. All right.